Okay, welcome everyone to the DevOps Meetup. Actually, we were lost a bit for a couple of months, just busy with the personal stuff and all. So we are back again, and hope everyone is doing great. So if this is your first time listening to Noorain, then what I can guarantee is like you guys will love the way he convey the message and all. So so this is how we're gonna do it today. Like we will have a short introductions by Noorin, and we'll get into the topics, OPA. And I'm really excited for today's event because it's something that I have not implemented it. So maybe this will be a knowledgeable session today, and hope everyone will learn. So without further ado, let's get started. So the mic is yours, Nuren. Let's rock.
Awesome. See, it's not great when somebody sets really high expectations. That puts a lot of pressure, my friend. I'm not ready for it. Remember, I'm coming out of a hiatus myself, right? It's been a while since I've been presenting. Uh, so okay. Introduce myself, right? So my name is Noorain. You guys can call me a tech bud. Right. I work at a company called Zapier. It's a services-based company based out of the US. My job here, even though it's a services company, I head the product engineering for Kubernetes, wherein we create solutions in and around Kubernetes to simplify its adoption and accelerate it for enterprise clients. And when we talk about enterprise clients, it's mostly targeting BFSI, the industry BFSI. So it's a heavily regulated industry. Uh, so some interesting set of challenges, and one such challenge, actually, I wanted to present with you guys, right? So I'll be sharing my screen now. Just let me know, Tara or Raju, once it's visible.
Yes, yeah.
And I finally managed to get another screen as well. So if you guys have questions, because I understand this could be a new topic for quite a few of you, uh, do ask questions. If it's related to the flow, directly in chat, or you can put it on the Google Doc as well, because it'll be easier to address it right there and there, just because of the nature of the topic, right? So whatever you're comfortable with, guys. All right. So policy management. Or before we actually start, I want to see if my second screen is working. All right. So everybody, put in a chat message. I mean, I want you to answer a question for me right now. Have you guys used Kubernetes in the last 6 months? If you have, just put in a yes, just so that I know the chat works. I'm gonna put that. Okay, we're getting guesses. That's good. That's good. Great. All right. The more difficult question: how many of y'all have implemented some kind of governance or policy around Kubernetes? Like who's allowed to do what and things like that. Even setting up RBAC is a form of governance, by the way. So if you set up RBAC, that's a yes as well. Jonathan, you have? Wow, great. RBAC, fair enough. Sounds good. Okay, great. So I think we do have idea of RBAC at least, right? So that's actually a good start. That's governance as well. So today I'm actually going to be talking about, oh, now since I know the chat works, right? I want activity there. Yeah, that's my source of power. That's my source of energy. If the chats don't work, I shut down. It's happened before, I just shut down. Uh, all right. So shifting policy management left. Like I said, it's about how you govern Kubernetes, right? Uh, I'll start with some context just so that you get an idea of what nature of work do we usually deal with. So again, just a little bit about Zapier. Like I said, Zapier is a services company, right? We work with like what 4 or 5 out of the top 10 private banks in India. And I mean, and because of the scale, we are handling like millions of requests. I mean, all mission critical applications are being set up. We even set up complete digital banks from scratch, right? Which is like a huge undertaking. And anybody aware of the banking industry, it's heavily regulated. It's slow moving. There are knobs for everything, and you have to be really, really careful with what you're doing. But luckily for us, actually, everybody's moving to the cloud. Everybody's understanding the need of DevOps, so that's there. I mean, it's not ancient times. We're using Kubernetes. Yes, we have some DevOps practices, Uh, but our DevOps practices cannot be brittle, right? Even a small failure can cost a lot of money to the bank, because again, it's a bank, right? We're dealing with transaction, we're dealing with money here. So what are the issues which usually lead to downtime? Let's start from there. So we did an analysis, right? We did an analysis with most of our top customers, and you know, very funny actually. Most of the downtimes. When I say downtimes, I'm not talking about a major incident. It could just even be, a pod restarting or some crashes or some timeouts happening. Most of these were actually because of misconfigurations, right? So it's not a bug in the code which was causing the problem. It was just that the configuration files which were supposed to be given to it were wrong. So misconfiguration was one of the biggest problems. Another problem which causes downtime is uh, access control. So since you guys have used RBAC, you all know that Kubernetes RBAC is fairly straightforward, right? It gives you single level access. So I mean, you can allow developers to read the pod logs, or you can allow your support team to read the pod logs, read the events, and things like that. You can control who's allowed to create a secret or read a secret, right? But it doesn't go for the second layer of access control. For example, which deployment is allowed to use a secret, right? Which deployment is allowed to use a secret? Which deployment is allowed to be exposed via an ingress? Those kind of second level access control, uh, it just doesn't work, because the operators working inside, they technically have full privileges and they can mount any secret they want. I mean, if you're running a pod, you can technically mount any secret you want in the pod and read the contents. There's nothing you can do to stop that. Uh, right. So, I mean, those are some challenges, right? These are things which causes problems. So yeah, Kubernetes, right? All of our deployments, most of our microservices workloads run in Kubernetes. Now, when I say misconfigurations, right, I'm not just talking about the YAML files which your application or your microservice needs. The thing is, nobody uses a vanilla Kubernetes cluster anymore. We have tons of tools which go along with it, right? You might be using a service mesh like Istio. You might be using some observability tools like Prometheus, Jaeger, Kiali, and things like that. You probably have some logging shippers installed like FluentD or something. You could have Canary or progressive delivery with Argo. I mean, there are so many tools. Uh, I mean, I don't even remember the number of tools that we deal with. It gets pretty intense. And the funny thing is that all these tools have to be configured separately. So you end up having a master Helm chart, a Helm chart which gives you nightmares at night. At least mine does, because you have all these various permutation combinations in that Helm chart. Your values file is like chaotic, and no single person knows exactly what it does. There are 10 people who have to work on it together. I mean, that's what it eventually becomes. So making sure you're configuring all of these tools to work together, right, is where most of the challenges come in. So again, when I'm talking about misconfiguration, I'm not just talking about single resource configuration. I'm not talking like, okay, make a proper deployment object. That people have started nailing down now. We do that. The problem which usually arises is when there are multiple resources which need to talk to each other. Let's take an example. Okay, so let's start with single resource misconfiguration. What do I mean by single resource configuration, right? Simple example, running as non-root. So I want to make sure that whenever I deploy a pod, it doesn't run as root, because running it as root has a lot of problems. I mean, you should never do it. It's a big security vulnerability, right? Uh, do you guys run as root? How many of y'all run as root still? So you know what I do sometimes, only for my dev. Okay, but that's just the one thing. But you shouldn't, right? Now I need a mechanism wherein I can basically say that nobody is allowed to run as a root user anymore. So Kubernetes gives you the security context. Like in a pod, you can have the security context, which can be specified on the spec level for the pod or on the container level. You can do it at both places. And you need to make sure that it's there at least in one place. So either it's here or it's on the container level. But you have to make sure that your container doesn't override the settings here. the point is you need to configure the security context. Some other things could be liveliness probes, right? We have a policy of never using exec commands for liveliness probes, or any kind of probes, in fact. We mostly use HTTP-based liveliness probes because TCP and exec-based are not very accurate in nature. Uh, so I mean, those kind of policies, right? So every pod deployed or every deployment deployed should have a probe, and it should have an HTTP probe. These are some single resource configuration which I'm speaking about. But again, that's not where the real problem is, because most of us have been nailing down how to configure a deployment. Now we've been doing it for years. We've been getting dreams about it. I mean, yeah, it's at the back of our hand right now. The problem is for multi-keys, like multi-resource. So one classic example, HPA and deployment. I bet you face this. I mean, I have. I still do. But if you have an HPA along with a deployment, you should not specify a replicas field. Can anybody tell me why? Why can't you specify a replicas field when you're using an HPA? Any idea? I think I'll answer that. But if I'm production, and so because I'm deploying a deployment immediately, as soon as I put that deployment in my Kubernetes cluster, all my instances will die because the replica is supposed to be one, and the HPA will kick in after a few seconds. So the number of replicas will scale back up, but it's after a few seconds, and that few seconds is enough for your application to have a cascade of errors, right? All your circuit breakers will trip. It's a disaster. We did that recently, and I'm ashamed of what's happened. But yeah, we had this problem, right? So I mean, how do you make sure that your deployment doesn't have replicas? Only if you have an HPA, right? Because not all deployments would need an HPA, and once which do, you cannot define a replica on it. One classic example. Another one. This is again something we faced not in production in a pre-pilot phase, but so everything works. So we had a application set up. I mean, we had a proper environment. Dev, everything works on dev. We send it for user acceptance testing. Everything works there as well. But as soon as we put it in pre-pilot, things just stopped working. Nothing worked. I mean, if you exec into the pod, actually you cannot exec into the pod. If you start another pod and try to like ping the pod directly, you're able to communicate with it. You're able to curl the pod directly, but it's no ingress traffic seems to reach the pod at all. No matter what we try, it always sent a route not found. So 404. And we just couldn't figure it out. We saw the ALB, we saw, I mean, we try to debug it as much as we can. The problem was that in our pilot environment, in our pre-prod environment, we had a stray ingress. So, okay, one thing, in Kubernetes, you can use Ingress to set up ALBs, right? So you can configure your ALBs, your application load balancers directly using this Ingress. And now we had a stray ingress in, okay? And that ingress was actually listening for a host, right? And nobody was using it, but it was set up for a host already. And it had a path prefix of /, right? And now my subsequent microservices, which created their own ingress, had the same host, but for a nested path. Now the problem was that the stray ingress was capturing all the traffic because it was having the same host and on the root path. And there was no way to figure this out. I mean, we had to it was in our namespace which hadn't been used for ages. So we had to actually check out all our ingresses, have to check out which ingress is causing the problem and which route is actually hijacking all our traffic. And this was actually the problem. There we had a internal app for testing. It was already there in pre-prod, and none of our new applications could receive any traffic because this one ingress was hijacking everything for us. So, I mean, now we are talking about the relation between two ingresses, right? So no two application can have the same host, or maybe no application can be on the path, right? You don't want to like whitelist all the traffic there. So these kind of misconfigurations happens a lot apparently, especially when you're doing things like progressive delivery, when if you're changing routes all the time. It happens a lot. And my favorite, because I'm a big fan of Istio, uh, authorization policies. So by default, in our clusters, we employ a concept called zero trust, wherein no service is allowed to talk to any other service, right? So nobody can talk to anybody else. Meaning, if you deploy something, it's useless. Nobody can talk to it. What you have to do is you have to deploy it alongside an authorization policy, which basically whitelist who's allowed to talk to me as in the service, in this case, my app. So who's allowed to talk to my app? And my app will control that, right? Uh, Now, if you do not deploy this, that my app is useless. And not everybody understands how Istio works. And debugging Istio errors is actually very difficult. So if you miss this out, figuring out that you've forgotten to apply an authorization policy becomes very tricky. So now you need to make sure that whenever I have a deployment in, and we have a release, we need to make sure that the authorization policy is also configured. These are the kind of complicated governance policies I'm talking about, right? And these are just three examples. Based on the number of tools that we use, there are so many use cases which keep popping up. But this is what I really mean by the governance standpoint, right? Wherein we have a bunch of conventions, we have a bunch of standards, practices. I wouldn't call them best practices. There are no best practices, but we have a set of practices, the way we do things. Just one slight misconfiguration, like disabling the authorization policy or using an incorrect host in your ingress, can cause problems in production. And there is no way to figure this out unless you actually face the problem, right? uh, so we want some constraints or some rules or some mechanism wherein not only can we detect violations of these policies but also prevent them from happening. Does that make sense? Does it? Guys, give me a thumbs up or something if this works. Give me a yes. Give me a yes if you're following with me on chat, if it makes sense. Yeah? Great. Perfect. All right. Now, this is where OPA Gatekeeper comes in. So, again, we're talking about a structure. So, our requirement right now is very clear, right? We want a structure. That structure is to enforce the practices which we have. That's all we want. I mean, in a simple nutshell, because Kubernetes leaves this to actually, Kubernetes just doesn't do it. I mean, so OPA Gatekeeper is a tool which does precisely that. So how does it work? Okay, how does OPA work? And then we look at how to use it. How much time do I have? I think I have some time, right? Great. So first we'll talk about how OPA works. All right, just so that we have an understanding on the operational aspects. Then I'll show you one sample policy on how you can use it. All right. So OPA works as a validating admission webhook. Now, okay, this is interesting. I'm not sure how many of you all are aware of admission controllers or admission webhooks, but the idea is that the Kubernetes API, the kube API, right, which kubectl talks to or Helm talks to or your CD pipelines talk to, these APIs are pluggable in terms of middleware, right? So there are two kinds of pluggability which it gives you by default, which is one to validate. So you can validate if the incoming request is valid or not, or you can mutate, right? Which is again very interesting, but we want to look at the validating part. So whenever a request comes to kube API, right? So whenever somebody does kubectl apply, by the way, this is me. I'm cute. I'm not ashamed of saying that. So this is me, a Golang fan, a gopher. I do kubectl apply, comes to Kubernetes. Now, instead of Kubernetes applying this resource by writing it into etcd, it will first call my service. It's a webhook. This webhook will get the entire payload of whatever you got in the request, right? So if you're applying a deployment, so in Kubernetes, you can apply only one resource at a time. That's what Helm does as well. So each resource will be passed in as the payload to our microservice. Our microservice can do anything. In case of a validating admission webhook, it can just allow it or reject it, right? So now we have a mechanism wherein I can enforce policies directly on the kube API. So assuming I have this framework ready, assuming I already have a mechanism to validate these payloads, Now I can enforce policies for everyone because it's directly for the kube API. So if somebody is doing kubectl apply, the policy will be enforced. If your CD pipeline is doing something in production, again, your policies will be enforced. If somebody is trying to use Lens or some, I don't know, UI, why are you using UIs? But okay, I won't judge. Your policy will be enforced. And that's the beauty of it, right? Just by implementing one webhook to validate your payloads, you can now enforce policies across the entire board. And this framework of how you can define rules is where OPA Gatekeeper shines. So OPA Gatekeeper is a policy engine which is using validated admission webhooks to capture the incoming API request, take the payload out, check if the payload is valid or not, and then allow it or reject it. Make sense? Sounds good? Awesome. So let's have a quick demo. So what I've done for you guys is I already have a Kubernetes cluster running. Is my Visual Studio Code visible? I mean, is my VS Code visible? I
Yeah,
hope it's not my presentation. All right, great. So what I've done for you guys is that I've made a simple policy. Okay. Now I'm going to scare you a little bit. This is how you write a policy. If you're scared, great, hire me. I'm kidding. It's a language called Rego. Rego is the language of writing policies in OPA or OPA, right? Uh, I'm not going to get into Rego for now. Rego is just one language. It's syntax. It's very weird. So if you come from a imperative programming language, like if you're a Golang guy or a Java guy or a C++ guy, Rego is going to feel very unfamiliar to you. It's alien. It's like, read this. Like, what is this? I have no idea, Uh, but in a nutshell, what this policy is trying to do is check for tags, right? It's just trying to check which tags are allowed or not. So, I don't want to allow people to use the latest tag, right? They have to use a version tag. Latest tags is not allowed in my cluster. That's my policy. Now, this is a bit overcomplicated than it needs to be because we've tried to capture a lot of edge cases. And there are a lot of such pre-baked templates, as OPA likes to call it, templates, which are already defined by the OPA Gatekeeper library. You can just use it. This is just one of them. And like I said, it's a template. This by itself will do nothing. Okay. So when I kubectl apply this, it does nothing. It's just a template. This template accepts input parameters, right? So whenever I create a template, I define what parameters I want. Like in this case, I want a tag, which is an array. I need to initialize this template by creating something called the constraint. And here I'm putting my tags. So I made a template. I gave it a kind. OPA will go ahead and create a new kind, a new resource altogether, right? So it's KATS disallowed tags. It made a new kind altogether. And in the spec, I can pass in the parameters to it. So now I have one template, and I can have one template for my dev saying that, okay, in dev, latest is allowed. But in my prod, latest isn't allowed, right? So, I mean, this way you write your template once, but you can have different constraints for different environments or different workloads or things like that. So this particular policy which I've written is going to be enforced only for deployments, stateful sets, and pods. And it's going to match all labels. Similarly, I could have grouped it for namespaces. I could have grouped it for particular set of labels, and I can change the attributes. Hope that makes sense. I know this is not that straightforward. There are other tools in the market which are way easier to write and way easier to understand than this. OPA has a bad reputation for this. Rego is kind of complicated, and the way they've arranged it is really complicated. But the advantage is, like I said, you can make your template library, and then your support staff or your operators of your clusters can decide what policy is applicable and pass the values to those policies. So let's do that really quick, right? I've already have a policy in place. Yeah, I already have this policy. I've already applied it, right? And I have a deployment object. And this deployment object is using the latest tag, which isn't allowed, by the way, because I put a policy saying latest is not allowed. Now, if I try to kubectl apply this deployment, So if I go to my terminal, clear the screen, and just put in kubectl, apply this deployment file. You see, kube API, see, there's nothing fancy happening here. Kube API itself is throwing me an error. Admission webhook denied the request. Which one? Container nginx uses disallowed tag latest. So now if somebody had misconfigured their Helm chart or just did a kubectl edit for some reason, it wouldn't go through, right? I mean, it's just like magic. I mean, it just works. Your developers need not even be aware of what OPA is. For them, the policy management framework just doesn't exist. It's just that kube API. I mean, Kubernetes somehow has become smart enough to understand what my practices are, which is great. So it plugs in all your tools, everything. Now, if I change this and I correct it, I'm going to put a incorrect tag, doesn't matter. Now, if I try to apply it, it goes through. That's OPA. Provide templates. There's a template library. You can write your own if you have a little bit of knowledge of Rego. Then create your constraints based on those templates, apply them, and that's it. It works. But life isn't so easy, you know. If things had to end here, well, the presentation would have been short, and I get another 15 minutes to torture you guys. So I'm not going to leave that. We've got one problem here. So OPA Gatekeeper has a big problem. So when we were using it, so this is what we did, right? We saw OPA Gatekeeper. We wrote all our policies in Rego because we were already using Rego. Actually, we were already consumers of OPA, so we love Rego. We already knew it, but then we started, noticing that there's a problem. So this is how it usually works, right? So again, that's me, the cute guy. I write some Kubernetes manifest, and then what's the usual CI/CD workflow like? I check my code in, right? I take a PR, I check my code in. So in the PR, my CI will run. My CI for my code runs, and then perhaps CI for my Helm charts will run as well if there are any CI processes for your IAC components. If everything look good, you merge it in, and then your CD runs, right? And then your CD is what will then deploy those Helm charts, build the I mean, really depends. I mean, I'm assuming you're building your image in CI, so the CD would be responsible for doing Helm upgrade. That's how it will usually work, right? Yeah. Now, if you have OPA, you get errors while your CD. But remember, I said that we are mostly dealing with BFSI customers, heavily regulated. For them, going from code all the way to CD takes a ridiculous amount of time, a ridiculous amount of approvals, especially if you're talking like production environments. So if your CD fails because of a policy violation, it's frustrating because now you have to do the entire process again. And trust me, DevOps sometimes makes things really, really irritating. So we need something smarter, right? We need our policies check to happen directly on my CI layer. I want to shift it left, closer to my developer. And that's what I mean by shift left. OPA doesn't do this. I mean, OPA just cannot do this. OPA works on the CD. I mean, it uses the admission webhook controller, right? I mean, how do you do this? Now, that's where the beauty of OPA comes in. OPA is actually a library written in Go. So if you are a Go developer, again, the cute guy, you can build your own OPA gatekeeper, right? So OPA is the library. OPA gatekeeper is the admission controller part. So now what I've done is I've written some code which tries to emulate OPA gatekeeper action on my CI. So I'm making my own CLI now, right? So I'm hacking. Now this is where we get into the uh, cool guy with a crazy terminal. Actually, you know what? This line won't work for you. So usually I show this presentation to people who are not from a very tech background. And when you open a terminal with code, they freak out. They're like, whoa, this is next level stuff. I even open a green screen for like Matrix and stuff. They get totally impressed. Not gonna work for you guys, but okay. I made a simple CLI. Okay. The first thing I'm doing is I'm grabbing the template. right? Grabbing the template, which was this file. This is this is extracting the Rego part of the entire thing. Because see, at the end of the day, this is just YAML, right? It's an object. So I'm grabbing my Rego, right? Then I'm grabbing my parameters. Parameters is this piece right here. Okay. So I am dragging my, so I'm picking up my Rego, I'm picking up my parameters, and then I'm picking up my object, which I need to use, like deployment or YAML in this case. And then I'm evaluating the Rego policy myself. Now, okay, this is just like kind of like pseudocode, but the implementation is right here. Don't worry, this is on Git. It's already on Git. You can check it out. You can make it like a little more robust. But yes, we are doing a dry run. This is a dry run. Unfortunately, OPA Gatekeeper doesn't support dry runs because it's working with an admission controller, right? So we wrote our own CLI to do a dry run of the policies on the CI layer. There are some tools like conf-dash which kind of do this, but they will force you to rewrite your templates. Right? So I just want to write my templates once, which I can deploy using OPA Gatekeeper, but the same thing should work on my CI layer as well. And this technically lets me do it. Right? I mean, I can just emulate Gatekeeper myself. So that's what we've done. Now this is just a demo, okay? I mean, I don't assume. I mean, please don't use this directly in your CI pipelines. It needs to be made a little more robust. But this is a good reference point you guys can use if you're interested. So I have a binary now, OPA Gatekeeper. Now, if I run this binary, oops, sorry. I'm supposed to make arrows first, right? Latest. That's the image not allowed. Run. So now my binary is giving me the error. I did not even need a Kubernetes cluster to be up and running because I'm emulating OPA Gatekeeper action directly in my CLI. Right? So it's a static check. It's a dry run. And if I fix this, well, you already saw that it works. So this will work as well. Looking good. This means I can very easily or smoothly extend OPA to make things as close to the developers as possible. I mean, right now we're implementing it as a CI step. So in a CI step, all our Helm, I mean, we run this tool, which automatically templates out all the Helm charts and everything. And then it automatically extracts the OPA policies and stuff. It applies those policies. So we've written a little bit of a solution for that. Unfortunately, not open source yet. I'm trying to get it open source soon. So you guys can have it. You'll be the first to know that, okay? So yeah, I mean, and then you can just run it on your CI step. But if you're using an IDP, right? If you're using a tool which auto generates Helm charts for you, you could embed this in your IDP directly. So a developer wouldn't even be able to check in code if their policies are being violated. Right? Make sense? Does that make sense to everybody? Give me a yes. Guys, give me a yes. Right. So my last thing, why OPA Gatekeeper? Right? Why? I mean, there are tools like Kaibono. I love Kaibono. It's amazing. There's tools like the tree. The tree is amazing. So why OPA Gatekeeper? For us, we love Rego. So it is scary, I know. It's amazing if you want to freak out your junior developers. Just get them on board, tell them, show them a Rego query and say they have to reproduce it. God, the look on their faces, it's priceless. I'm telling you, try this at home. It's fun. But if you get past the complexities of Rego, it's really powerful. I mean, the same Rego policies, if I had to write it in a programming language like Go, it would be at least 3 times as long. Right? Rego is amazing as a policy engine. It's an amazing language, especially for the kind of policies which I was talking about. Rego is amazing. Rego is cross-functional. So remember I told you that we were already using Rego. We were using Rego for on our API gateway level. So on our API gateway level, we often have to implement authorization checks, right? Like rules of who's allowed to do what. Only admin is allowed to do this, blah, blah, blah. So obviously there are some more complicated authorization checks than that. And we were using Rego for that actually. So we had a middleware for evaluating Rego expressions to perform authorization checks. In fact, it's such a common use case that if you're using Envoy, which is, by the way, the proxy used by almost all the service meshes out there, it has first-class support for Rego, if I'm not wrong. Most API gateways today, Kong, uh, not Nginx. Okay, Nginx is nobody uses that. I think Traffic as well. Yeah, Traffic as well. These guys already use OPA. Oh, sorry, Rego. So I mean, it's cross-functional. So if you've learned Rego for your governance for Kubernetes, you can use it for your API traffic. Raju and I were just discussing. You can also use it for your Terraform. You can use it to parse your state files. You can use it for anything, any kind of policy evaluation. You can use OPA. So it's cross-functional. Learn it once, use it everywhere. Uh, it's highly extensible and written in Go, so I can extend my own OPA policies. In fact, you can even call functions from within Rego. So I can call Go functions from within Rego. So I can extend the functionality of Rego. I mean, it's insane. It's completely extensible. It's all in Go. You can embed it in Go. You can embed Go in Rego. It's insane. And particularly for Kubernetes, it's the only tool right now which supports the multi-resource use case. Is the only tool which can actually inspect the state of the cluster, say that, okay, if an HPA was available for this deployment, replicas is not allowed. That's the only tool which does that as of today. So actually, I should have started with this because that's the main reason. We just had to use OPA Gatekeeper because no other tool, at least at the time, did it. And I'm pretty sure no other tool does it right now as well. So that's it, guys. That's OPA Gatekeeper. Actually, OPA to be more precise. It's the policy engine we use at Zebia. We love it. We've been using it for more than a year now, just in Kubernetes. I mean, before that, we've been using it for API gateways for like years and years. I think it's a CNCF project, if I'm not wrong. I don't know. I'll have to check. Give it a try. It's amazing. You need not even use it for Kubernetes. You could use it for anything, but OPA Gatekeeper is a good starting point for policy on Kubernetes. It's got a bit of a learning curve, but once you get past that, it's amazing. It's the most powerful tool ever for policy evaluation. And if you like this talk and you want to see more content like this, you can check out my YouTube channel. It's called Backstage with Architects. I talk about DevOps. I talk about things like Istio. Also talk about a little bit of programming like microservices and event-driven architectures. So do subscribe. I would love that. Please do. You can reach out to me on Twitter. I'm your tech bud, or just reach out on LinkedIn. That's fun as well. It's a CNCF graduated project. Oh, I had no idea. Right? OP is in CNCF. So, yep. Thanks a ton, guys. Hope this was helpful. Hopefully, you followed some. I will share the code and the examples with you. I mean, I'll share it. It's on GitHub. You can just check it out. All right. I think this is the time when I can start taking questions. Whoa. Was it that boring? Everybody's gone to sleep?
We have two questions in the docs. Can you see the docs?
All right. Acha, I'm supposed to open it. One second, let me open it. Chat. All right. All right. So yeah, I see the questions. So admission webhook is checked even while doing kubectl edit. Yes, it is. Any kube API call, the admission webhook will be called. All of them. So yep, it can. In fact, patch statements. I don't know how patch statements are handled because technically in patch you're just getting a subset of the payload. So I'll have to check that. I've never tested it with patch statements. I'll have to check that. But you can, as a bypass, you can even use OPA Gatekeeper in an audit mode. So instead of enforcing it on the webhook layer, you could also just let it run as an auditor. So it will scan all your resources in the cluster and just print out or dump the violations on. So it's not enforcing in that regard. So I mean, I think that could be a bypass for patch, but I think so. There should be an easier way to handle patches. I need to get back on that. But kubectl edit, yes, it works, because even in kubectl edit, if I'm not wrong, it sends the entire payload again. Okay, second question. Is there a fancy, lazy way to write templates? The laziest way is just checking out the OPA library, OPA Gatekeeper library. I think they have a link to it in the official docs. I'll send a link to that as well. Uh, is there a Rego generator for more complicated use cases? Not really. So like I said, right, Rego is complex. A Rego policy is more concise than what you would have otherwise done in code. So auto-generating Rego would be really difficult. Yes. So if you want like a drag and drop tool, I've not seen one for Rego. In fact, I wouldn't even recommend it, because uh, you're losing out a lot of flexibility of Rego. The only reason why you would undertake something like this, if you want the flexibility. Otherwise, using tools like Kyverno or Datri, actually, Datri is pretty good. They have a lot of baked in policies, so you don't have to write anything. That would be perhaps a better thing. So you're only using OPA Gatekeeper for the flexibility. Uh, otherwise, I I wouldn't suggest it, because Rego is the good thing about it. Can it be used to enforce network policies as well? All Kubernetes resources. So if you have a Kubernetes, I mean, if whatever you're describing is a part of is part of the kube API, right? So I mean, it's a resource which you can deploy via kubectl apply. Yes, you can have policies for it. Uh, you know what? I'll just share my screen once again to highlight a point, because I didn't highlight it earlier. When you're defining a policy, hope my screen is visible. When you're defining a policy, you have to explicitly mention what resources this policy will be applicable for. So my disallowed tag policy is applicable for deployments, stateful sets, and pods. So if you wanted network policies, or you know what, even if you wanted a CRD, like virtual service for Istio, or any CRD for that matter, you have to just give its API group and give the kinds which is applicable, and your policy will apply for that. So it's for anything which can be deployed via kubectl apply. Uh, but again, like I said, OPA is a library at the end of the day, right? So even if you wanted to use OPA for non-kube apply stuff, like you wanted to validate the vars of uh, of Terraform, uh, you'll have to write some custom code, but you can use OPA for it. OPA Gatekeeper is for Kubernetes. OPA is the main library or the main Rego guy. OPA is the root project. OPA Gatekeeper is just an extension, which is the webhook controller part, just for Kubernetes. Just to be clear. Yeah, hope that answers the question. Oh, sorry, Raju. I think I took the sharing away from you. I didn't realize.
No, it's not that.
Yeah, and Kadakoda has been dead for a while now, in fact.
Yeah, I just checked and like never saw
Yeah,
because it would have been really easy for applying and learning through Katakoda. So,
yeah.
yeah.
I think there's an interesting replacement for Karakoda which has come up. I forgot the name. It's pretty much like Karakoda, but the resource is a little less extensive.
It's something with playground name.
Yeah, I totally forgot.
Okay, so one question from my side. So we don't need to run any kind of the agent, or it will not consume any resources on the Kubernetes itself, right? For
All
implementing
right.
policy.
Sorry, I did not mention that. So before you deploy your templates and your constraints, you have to install OPA Gatekeeper. So OPA Gatekeeper is installed as a 2-pod setup. There are 2 pods as a minimum. Actually, the minimum is 1 pod. So you need a pod, right? Because your validating webhook has to hit some API. So there is one long-lived service from OPA which always has to run, and it will consume resources, and these are critical resources. So by default, if your OPA pod is down, your kube API will stop working because your validating webhook itself is down, right? So think of it as kube API itself being down. So yes, you have to deploy OPA Gatekeeper. They have your helm chart. You can directly just go ahead and use that, and it will take some resources. But most of us don't use Coop API a lot unless you're a person who using the dev cluster directly using Coop commands, Coop cutter commands. In that case, your resources would be less. But i- sorry, in that case, your resources would be high. Otherwise, usually it's really less.
Hmm.
But yeah, you are running something. Sorry, I missed that. You have to install OPA Gatekeeper first.
Yeah. Okay, and also like apart from the Kubernetes implementation, I saw it can be implemented on the application as well. Like
Yeah,
the API can have put request or post request to some only path or something like that.
right.
Yeah, that's interesting.
I have an example of that. Do you want to see it? One sec. Let me check if I have one.
Yeah, I think we
So,
can.
so actually, my old project, I have it. Oh, oh, I know exactly what to show you. This is a really cool example, and this is why I love OPA. One second. Let me look for it. It should be right here. So we use GraphQL a lot. Okay. Uh, uh, One second. Where did it go? Got it. Sharing my screen again. Sorry, Raju. I keep taking the screen sharing access from you.
Yeah, I think like we finished the talk. So yeah.
All right. All right. So this is the piece which I was speaking about earlier, wherein you can use OPA outside of Kubernetes as well. Uh, Now this might be a little confusing because this is another open source tool which I'm the maintainer of. It's called Space Cloud. You can check it out. It's a GraphQL automation tool. But oops, yeah. But what I can do in OPA, right? So let's say I have a REST endpoint, right? Now this REST endpoint is made out of a GraphQL query, which is secondary. Just imagine you have a REST endpoint defined, right? So you have a route in your API gateway, right? So you have a URL, a method, you probably even have a domain. Now, as a plugin, most of these API gateways give you a plugin system, right? As a plugin, what you can usually do is you might have an OPA plugin, and there you can write your OPA policy. So what I'm technically doing in this OPA is I'm setting whether a resource is allowed or not. I mean, should I allow the user to, add Pokemons or not? And you can do that as simple as just write some code here. Uh, Now this OPA policy is actually, firing GraphQL queries. So there are GraphQL calls being made from my policy engine. That's how flexible things can be, you know. So try to fire a GraphQL query. If the GraphQL query is perfect, only then will it return. Let me show you an easy example. Uh, I want to allow the request only if my claims, my JOT token claims, contains admin. So if the user is part of the admin group, only then allow the user to fire the request. So again, I don't have to put loops and things. Remember, I told you it's pretty concise. So groups is an array. All I can do is just put an underscore as a don't care, and it will automatically understand that I need to loop through all the groups. So it's like an in clause, right? It's like an in clause. Uh, Now this is an easier example of OPA or Rego policy, but I can just define this policy. My API gatekeep, my API gateway will compile this query, and it will have a sub-millisecond execution time for such things, right? And I mean that's how easy it is. You just define your policies. Like you can use your token claims, you can use your request methods, you can use your request body, you can use anything you want. uh, and like I just mentioned, you can even put HTTP calls or GraphQL calls or database calls directly from your policy. Again, not a good habit to do that, but if you needed that kind of complication, you can do that. And all of this is generic, so you don't have to code anything. Like I don't have to like change my API gateway code. I can insert this logic, which is doing all this crazy stuff without having to worry about it. Yep, that's an example. Not sure if it helped, but this is how most of the API gateways will kind of let you use OPA as a middleware, as a plugin.
So this will go to, let's say, if we are using nginx ingress or something like that. So this policy will go in there, or where do we write these kind of policies like specific to this API?
That's a good question. Each API gateway handles plugins their own way, right? So Kong has a UI where you can do all of this. But
Mhm.
if you're using Kong via the Kubernetes controller, uh, you define this all in config maps. And then in the ingress, you just mention the config maps you want to apply as a part of the ingress route. Uh, it's not a very clean way to do it because back then the gateway API did not exist. But the tool which I'm showing you right now, it's directly a CRD, right? So sorry, you know what, let me show you this one. There's a policy, there's a CRD called OPA policy. You can just kubectl apply it. The API gateway which we've written, again, it's called Space Cloud. It automatically reads this up, and then your routes can just mention. One sec, what's the name here? It's basic rule. So over here there might be some reference to basic rule right here. Yeah. So I can have a plugin which says that okay, uh, refer to the policy which I've written in the CRD, or you can define the policy right here itself, like what I've done here, kind of.
Okay, yeah, that makes sense.
But every API gateway you use will be different in this regard because there's no standard on how plugins are implemented in API gateways. It's just that because we love Kubernetes, everything to configure our API gateway is through CRDs.
Yeah. Okay, that's also like interesting implementation apart from the core Kubernetes only.
Yeah. And this is how we started using OP actually. Uh, yeah, it's really easy. I'm gonna check if it's admin or not. That's it. Just write this much and it works.
Okay, so anybody have any questions or thoughts or anything? Or just,
How many of y'all are planning to use OPS soon? Want to give it a shot or something?
yeah, I will definitely give a shot.
Awesome.
Okay, so I see like some of the implementations like in the Kubernetes, Envoy, Terraform, Kafka, SQL, and even Linux. Maybe I'm not sure. The SSS and the sudo authorization policies as well. So
Yeah.
not too much specific Kubernetes only. So
Yeah, it's not Kubernetes only.
mm,
Kubernetes is just one way to kind of do this.
okay, so anyone has any thoughts or maybe like something not related with this session as well? Just if you want to share anything you're learning in the past week or what you are learning today, or maybe after this session, just speak up something. Okay, nobody wants to opt in. Okay, so I will be updating this reference guide and channel also on the doc, so it will be a reference for future as well. Just click quickly in here so we don't miss out. Because like when you leave things, then it is left till another session. That's a kind of developer's way of doing things. Okay. So, oh, nice. Good luck for that, for your exam. Okay, so I think, yeah, we should be at the end. So thank you, Noorain. Thanks a lot for sharing and giving your time and sharing all of these things. Uh, really nice meeting you again. I met you in person as well for the first time, so it was like
Yeah,
maybe we'll meet sometime, someday, somewhere.
yeah, hopefully soon. It was fun being here. Thanks for inviting me.
Yeah. Okay. Thank you all, and we'll be connected, and maybe like we'll be organizing an offline meetup very soon. Maybe at the end of December. That will be kind of goodbye for 2022 as well. And I think anniversary celebration as well. I think there will be one in the December. So stay tuned. And if you want to share anything, or if you just want to lead meetup, then just let us know. Or if you find amazing place to do offline meetup, then just bring us in. Okay, so thank you all and have a good day and bye bye.
Bye.